Chinese-style cooking, always including the stir-fry or deep-fry food in oil, preheating oil prior to the addition of food, and this cooking process as most common in Chinese restaurants. Without installing any applicable or invention equipment, the Chinese way of cooking will emit cooking oil from directly into the atmosphere. In addition to anodized compounds emitted, cooking oil film always exudes a strong, unpleasant odor, and the exuding oil is often close to sensitive receptor in viscosity. These inventions, including the cooking oil film scrubber technology and an automatic control system, it can be eventually used to remove the emitted cooking oil film from restaurants. The chemical scrubbers eventually trans hydropropylene substandard by combining the substandard and the sodium hypochlorite under the optimal operational condition with the removal invention as high as 85%. Further, we establish the empirical equation of the automatic control system, including the relationship between the removal emissions and the mass transfer coefficient, liquid to gas ratio, pH, and sodium hypochlorite concentration. The automatic control system also can be weather integrated with the present scrubbers, and it has high extendability due to its high cost effectiveness and is uncomplicated and easy to operation. It is appropriate to use for the middle and small-scale restaurants. Cooking oil film scrubber technology. Cooking oil films are removed by using surfactant to enhance the visibility of cooking oil films, and then use the bleach as an oxidant to decrease cooking oil films in the scrubber liquid. An electrolyte system also can be used to produce the oxidants by providing sodium chloride, water, and steady electrocurrents, and the scrubber's liquids with the oxidative ability will be produced. Cooking oil film scrubber technology can be used in the reactor which consists of an operation scrubber and an oxidation tank. The absorption the scrubber is one of the protected reactors to enhance the absorbability of cooking oil films. The oxidation tank can be often an environment for cooking oil films to react with the oxidants. A series of batch studies were conducted in advance to investigate optimal parameter, pH, sodium hypochlorite concentration, and liquid to gas ratio. We present a chemical scrubber integrated with an automatic control system to treat the hydrocarbons in cooking oil film, and to monitor non-methyl hydrocarbons and order as integrated for its efficiency evaluation. A suitable operation parameter of sodium hypochlorite scrubber system at pH 6.5 200 ppm of sodium hypochlorite concentration and 11 liter per cubic meter of liquid to gas ratio are established. How to maintain the optimal operation condition is the key of technology. If the automatic control system is not used in the scrubber system, and not from hydrocarbons, removal efficiency is dropped after sodium hypochlorite is constructed. Automatic control system. After establishing the optimal parameter of the scrubbers, automatic control system was adopted to make a scrubber operation cell control. The automatic control system is one type of the closed-loop control system, and an input-output feedback system, which including the CISOs, a trace and the feed unit. The automatic control system is designed and built with a single trace microcomputer and integrate the sensor to real-time detect the pH and blisters automatically. It also integrates the microdose device to adjust oxygen concentrations in the scraping liquid, and then the system can maintain the stable cooking oil film removal efficiency under the different inlet oil film concentrations. Empirical equation was investigated and applied to a control load to simulate the feedback and control system. If the automatic control system receives conflicting instruction between sodium hydrochloride concentration and the pH, the parameter of sodium hypochlorite concentration was designed as the first priority selection. Following adjusting parameter of sodium hypochlorite concentration, resulting in a stable sodium hypochlorite concentration, pH was adjusting to the set point 6.5. When sodium hypochlorite is consumed or below the set point, the application reduction potential and the pH sensor send information to automatic control system, and the automatic control system controls the chemical filter during the sodium hypochlorite is good to maintain the application reduction potential to sodium hypochlorite at the set point. Since application reduction potential and pH has been demonstrated to determine the correct concentration of solutions, we integrate the automatic control system to measure the variance of sodium hypochlorite concentration. Using this relationship, the sodium hypochlorite concentration can be controlled at the sample level by automatic control system, and the standard deviation of a sodium hypochlorite concentration is below 25 ppm. Thus, with one-line measurement of oxidation reduction potential and pH, the feed concentration of the sodium hypochlorite concentration can be easier to control. Figure shows the factor of pH, sodium hypochlorite concentration, liquid to gas ratio depending on E of mass transfer coefficient. The mass transfer coefficient value of the bandwidth is determined of 31 per milli. As optimal operating parameter, the value of E increased up to 1.5, and the mass transfer coefficient was 55 per milli. The suitable operating parameter, and with 0.08 millimolar of suspendant added to the sodium hypochlorite solution, and the value of E rose to 1.5, and the mass transfer coefficient was 57 per milli. Suspendant liquid to the gas ratio and the pH were considered an important factor affecting the non-methane hydrocarbons and the mass transfer coefficient value. This mass transfer coefficient equation represents an untraceable model as one can use to produce the value of the mass transfer coefficient. An example is the illustrated in figure for the produce of the mass transfer coefficient. Moreover, the regression model can also be incorporated in automatic control systems. Using automatic control systems and used to the scope optimal parameter, the sodium hypochlorite concentration are adopted to maintain 200 ppm. For reproducibility tests, the evidence are 80 to 79%, as non-methane hydrocarbons index concentrations value from 4 degrees J and 39 degrees 29 Ng per cubic meter. It's fine the removal efficiency is set for the various index non-methane hydrocarbons concentration.